Welcome back to the deep dive. We're your shortcut to getting really informed on, well, sometimes complex topics.
Indeed.
And today, we're looking at something you probably see all the time but maybe don't think much about, the forklift.
That workhorse of warehouses and work sites everywhere.
Exactly. You might just think, okay, it lifts heavy stuff. But its environmental footprint, it's actually way bigger and more complicated than you might first guess.
Yeah, it's easy to just think about, the exhaust pipe, if it even has one. But our sources, especially looking at analyses like the one from Angus lift trucks, they show a much wider picture.
And that's really why we're doing this deep dive. Our mission here is to sort of cut through those simple assumptions, pull out the key insights from the material we've looked at, and give you a really solid grasp on how these machines affect the planet.
And importantly, what could actually be done about it.
Right. We're going beyond just the fuel. We're talking manufacturing, how they're used day to day, the whole life cycle. It's actually quite a fascinating journey from thinking it's straightforward to seeing all these nuances.
Definitely.
So where should we start digging in? I guess the most obvious place is the power source, right? How it runs.
Makes sense. That's usually the first thing people ask about: how green is it?
Yeah.
And basically, our sources point to three common options.
Okay. Let's start with the old standby diesel forklifts.
Right, the traditional internal combustion engines, they run on fossil fuels. And yeah, unfortunately, that means they have the highest negative environmental impacts straight out of the gate.
We're talking serious emissions then.
Oh, yeah. Carbon emissions, obviously, but also things like sulfur oxides, SOx, and nitrogen oxides, NOx. These aren't just vague pollutants. SOx contributes heavily to acid rain, NOx to smog and ground-level ozone. Plus, they're potent greenhouse gases themselves.
So real tangible damage. And I know they often cost less up front. They work well outdoors, handle the heavy loads. You can fuel them right there.
True, those are the operational pluses. But the flip side, more moving parts, they need constant refueling, which means, higher maintenance and running costs over time.
So if you have to use diesel, the advice is...
Look for the best fuel efficiency you can find. Get models with emission reduction tech. And interestingly, the source mentions using soy diesel can actually cut down hydrocarbon and NOx emissions somewhat.
Okay, so from diesel, let's swing to the other end. Electric forklift, often seen as the eco-champion.
And on the surface, you can see why. Zero greenhouse gas emissions during operation. That's a big plus. They also have fewer components, generally need less maintenance, just need charging. Sounds pretty good, right?
It does sound ideal, but I sense there's a but coming. Our deep dive suggests it's not quite that simple.
Exactly. There's this sort of hidden environmental impact. The big one is where that electricity actually comes from.
Ah, right. Unless your grid is 100% renewable or you're using your own solar panels, maybe, you're likely pulling power generated from fossil fuels.
Precisely. The source gives the UK as an example. Currently, only about 42% of their power comes from renewables. So charging that zero-emission forklift might still be contributing to emissions upstream. It clouds the picture a bit.
And it's not just the electricity source, is it? What about making the batteries?
That's the other big piece, especially with lithium-ion batteries, which are so common now. The mining of the minerals, the manufacturing process, that carries a significant environmental cost before the forklift even gets switched on. We'll definitely circle back to that in more detail.
Okay, so higher upfront cost for electric, potential long-term savings, but this more complex environmental footprint than just zero emissions.
That's a good summary. You have to look beyond just the operation itself.
So we've got diesel, which is clearly problematic, and electric, which is complicated. Is there a middle ground? Where does propane fit in?
Propane often gets positioned as that compromise. It's generally considered a cleaner energy source than diesel, producing fewer greenhouse gas emissions when it runs.
Is it renewable, though?
Well, standard propane isn't, no.
No.
But there is such a thing as renewable propane becoming more available, which could improve its profile down the line.
And the emission reductions are pretty significant, aren't they? I saw numbers like 76% less sulfur oxides and 94% less hydrocarbons and notarox compared to electric.
Yeah, those figures from the source are quite striking, especially for things that affect local air quality. Operationally, it's cleaner in that respect.
Trade-offs.
Cost-wise, they're typically less upfront than electric, but the fuel itself usually costs more per hour than charging an electric one. So yeah, each fuel type really has its own distinct set of pros and cons, environmentally and operationally. You have to weigh it all up.
Okay, this is really interesting. But what blew my mind a bit reading through this was that beyond the type of fuel, The sources suggest the actual amount of energy used might be even more important.
That's a crucial point. It's not just what powers the forklift, but how much power it consumes overall. The main goal, really, for reducing the environmental impact is simply to minimize the runtime.
How much do these things typically run?
It varies hugely, but the range cited is anywhere from 500 hours a year to maybe 3,500 hours. Every single hour contributes to that footprint. So cutting down operational time, regardless of fuel, is massive.
And the consumption figures you mentioned, even though the units are different, they show a big difference, right?
They do. Like propane uses about 0.35 kilograms per kilowatt hour. Electric needs only around 0.0417 kilograms of electricity input for that same kilowatt hour output, incredibly efficient at the point of use.
In diesel.
Diesel's figure was about 0.15 UK gallons per kilowatt hour. It's harder to compare directly without conversions, but it clearly relies on a significant volume of fossil fuel for the work it does. These numbers really highlight why reducing runtime matters so much. Even small efficiency gains multiply dramatically over thousands of hours.
And less fuel use equals less money spent, naturally.
Absolutely. There's a direct financial win. The source mentioned electricity costing around $7.42 per hour versus propane at about £1.10 per hour.
Yeah.
So using less literally saves money. Environmental goals and business sense aligning.
So how do you actually reduce runtime? What are the practical steps?
Well, the sources suggest looking for alternative ways to do tasks. Maybe not everything needs a forklift. Simple things, too, like actually powering them off instead of letting them idle.
Yeah, that seems obvious, but probably often overlooked.
Very much so.
Yeah.
And maybe running them for shorter, more focused bursts just to get the job done, rather than keeping them running continuously. These little behavioral shifts can add up to significant savings environmentally and financially.
Okay, that makes sense. Now, connecting this to the bigger picture, you mentioned manufacturing earlier. This seems like a huge, but maybe less visible part of the impact.
Oh, absolutely. It is one of the most significant contributors, but often flies under the radar. Think about all the materials involved, especially steel for the body, frame, boom, cab.
Right. Steel's got to be the main component by weight.
Exactly. And making steel starts with mining iron ore. That process alone uses heavy machinery trucks, generators, often diesel-powered, releasing loads of CO, sulfur dioxide, nitrous oxide, CO2.
And it's not just air pollution, is it? There's water contamination, too.
Yeah, acid mine drainage, heavy metals leaching into water sources. It's a major issue.
Wow. And then actually producing the steel itself.
Hugely energy intensive. The source states it takes about 20 gigajoules of energy to produce just 1 imperial ton of steel.
20 gigajoules? That sounds like a lot. Can you put that in perspective?
Yeah, it's roughly the energy 2 average European households might use in an entire year for 1 ton of steel. And often, that energy comes from burning coke, which is basically processed coal.
And burning coke isn't clean?
Far from it. It releases toxic compounds like naphthalene, and the process generates really nasty wastewater. The bottom line figure is stark. Producing 1 ton of steel emits about 1.83 tons of CO2.
So a key takeaway here is to look for forklifts made with recycled steel or reuse components if possible.
That's definitely a major mitigation strategy suggested by the source. It avoids a huge chunk of that initial manufacturing footprint.
Okay, steel is one big part. What about the batteries for electric forklifts? You mentioned lithium-ion earlier.
Right, the other major material challenge. Making those batteries, specifically mining the lithium, has its own set of serious environmental problems.
Such as?
Well, the mining process can leak toxic chemicals, including things like hydrochloric acid. These can contaminate local water supplies, killing fish, impacting livestock, cows, yaks mentioned in the source that drink the water.
And doesn't it use a lot of water, too?
An incredible amount.
Yeah.
Around 500,000 gallons of water are needed to extract just 1 metric ton of lithium.
500,000 gallons per ton. Wow, how does that extraction work?
Typically, it involves drilling into salt flats, pumping up brine that's rich in lithium salts, and then letting it evaporate in huge ponds for like 12 to 18 months.
That sounds intensive.
It is. And the whole process contributes to air and soil pollution in those regions, which can hinder local farming and generally impacts the quality of life for people living there.
And then what happens when these batteries reach the end of their life? Recycling must be key.
You'd hope so. But the reality, according to the source, isn't great yet. In Australia, for example, only about 2% of lithium-ion waste gets recycled.
2%. Where does the rest go?
Landfills, mostly. And there, they can leak those ionic fluids and heavy metals into the soil and potentially groundwater. Plus, actually recycling them effectively is hard.
How so?
The lithium cathodes, a key part, are difficult to process, Often the whole battery cells are shredded and then the metals are separated, sometimes by burning, which wastes the valuable cathode materials. It's problematic.
It really puts that whole electric is automatically green idea into perspective, doesn't it?
It absolutely does. It shows the complexity. So while research is ongoing for better batteries and recycling, right now there isn't a perfect, readily available alternative.
Which brings us back to propane maybe being that pragmatic, if imperfect, compromise for now.
Given the challenges with battery production and end of life, yeah, that seems to be how it's positioned.
Yeah.
Even acknowledging propane is still a fossil fuel, albeit cleaner burning than diesel.
It's not all doom and gloom on the manufacturing side, though, is it? The sources mention some positive examples.
Definitely. Toyota Material Handling, TMH, gets highlighted for making environmentally friendlier forklifts. Their facilities, for instance, achieve zero waste going to landfill.
Zero landfill. That's impressive for manufacturing.
It is. And they focus on responsible sourcing, getting 85% of their materials from suppliers who are ISO 14001 certified.
Which means those suppliers have proven environmental management systems in place.
Exactly. It shows a commitment throughout their supply chain. They also do things like cleaning water before returning it for treatment and using powder coat painting, which is generally better for the environment than liquid paints.
And they're encouraging others in the industry, too.
Yeah, pushing for more recycling programs for parts and oil, designing more electric and propane models, reducing their own energy use, minimizing pollution. It shows leadership can make a difference.
Okay, so we've covered fuel, energy use, manufacturing. What about waste reduction after the forklift is built? The life cycle aspect.
Crucial. And a big part of that, according to the sources, is simply investing in high-quality vehicles in the first place.
Because they last longer.
Precisely. Quality products tend to have a longer operational life. Those source notes, electric forklifts, might last up to 20,000 hours, potentially double the lifespan of a diesel one at 10,000 hours.
So less frequent replacement means fewer new machines needing to be manufactured, fewer parts needed.
Exactly. It reduces waste across the board, reduces the resources consumed in making replacements, and often translates to lower overall costs too, including fuel, as efficiency is maintained longer.
And tied directly into that longevity is maintenance, right? Keeping them running well isn't just about avoiding breakdowns.
Oh, it's huge for the environmental side too, though maybe overlooked. Regular proper maintenance prevents leaks of oils, fuels, hydraulic fluids, dangerous chemicals.
And keeps emissions down.
Yes, it helps keep emissions optimal for the engine type and extends the machine's overall lifespan, further reducing that need for replacement and lowering the carbon footprint over time.
What kind of maintenance are we talking?
The basics, really. Regular battery checks for electrics, consistent oil changes for combustion engines. These things directly maintain and can even improve fuel efficiency.
So less fuel burn for the same amount of work. Simple, but effective.
Very. And another key maintenance-related point is ensuring you're using the right forklift for the right job.
How does that fit in?
Well, for instance, using a diesel forklift indoors in a poorly ventilated space isn't just bad for worker health. It's releasing those pollutants where they're most harmful. Indoor settings really demand cleaner options like electric or propane.
So diesel should be strictly outdoors or in places with really, really good ventilation.
Ideally, yes. And even then, electric or propane might be pressable if they can do the job, just based on the emissions profile alone.
Okay, that covers the forklift itself pretty thoroughly. But the sources also mentioned looking beyond the machine at the whole warehouse environment.
Right, creating a sort of holistic approach to sustainability in the facility.
What kind of broader strategies did they suggest?
Things like optimizing lighting, switching to motion sensor lights so they're only on when needed, and using LED lighting universally.
LEDs are much better, aren't they?
Oh yeah, way more energy efficient, they last much longer, they're more durable, and have a lower carbon footprint overall compared to older lighting tech.
What about heating and cooling? Warehouses are often huge spaces.
The advice there is pretty straightforward. Try to keep the temperature range moderate, maybe a bit warmer in summer, cooler in winter than you might think. And crucially, invest in good insulation. That helps regulate the temperature naturally, cutting down HVAC energy use significantly.
Makes sense. Anything else?
Installing solar panels on the warehouse roof is a big one, especially if you're running electric forklifts. Generating your own clean energy tackles that indirect emissions issue we talked about earlier.
Creates a nice closed loop for the electric fleet.
Exactly. And finally, having robust recycling programs in place. Not just paper and cardboard, but specifically for things like used oil, packaging materials, and even old forklift components. Closing the loop on waste.
Wow. Okay, so just to recap this deep dive. the humble forklift. Its environmental impact is surprisingly multifaceted. It's not just the fuel.
Not at all. It's the direct emissions, yes, but also the complex footprint of manufacturing the steel, the lithium for batteries. Then there's the sheer amount of energy consumed during operation, the importance of maintenance for efficiency and longevity, and managing the entire life cycle to reduce waste.
It's a lot to consider. But the takeaway isn't just that it's complicated, right? It's that there are actually levers to pull.
Definitely. While the overall impact is significant, whether you're choosing a forklift, operating one, or managing a facility, you have real choices.
Yeah.
The type you select, how well you maintain it, how you manage energy use, even wider facility choices like lighting and solar.
All these things can make a difference towards a greener operation.
Precisely. It empowers you to make more sustainable decisions.
It really does. And it's a powerful reminder, isn't it? How even these really common, seemingly ordinary bits of industrial gear can hold these incredibly complex environmental stories. It makes you think. Well, given what we've uncovered here, what other everyday technologies, maybe in our homes or other industries, have similar hidden environmental complexities just waiting for us to really understand them?
That's a great question to ponder. What else are we taking for granted?
Something to think about until our next deep dive.